Here is the compass motor, or the compass magnet motor I like to call it. And you'll see on top it has a fishing swivel. And that's what it spins by. The swivel can freely turn. At the bottom it has no bearing right now. Now, in the middle, this is a bunch of big magnets. The red indicates the North Pole. So what the magnets do is, because they're a compass, they point north. So if I turn the armature, this whole thing is the armature, right? And underneath I have the electronics that controls this. If you can see in here, there's a little DC motor. And there's a 9-volt battery on the bottom and a microcontroller. And this is the remote control. This is the remote control. And the remote control, when I turn on the remote control, it makes the motor turn the magnets. Okay, so when the magnets turn west, right? That way is west. That way is west. When the magnets turn west, they make the armature turn north. Now that's really amazing because there's a lot of power there. I mean, we're talking about Earth's magnetic field and a couple of magnets, and look how it makes that whole armature turn. So the magnets turn the armature. So I'm going to turn that on, and you can see the magnets turning the armature. Right? So you got that. The magnets are turning, the motor is turning the magnets point west, and then they try to point north. They're like frustrated compasses. They try to point north, but the motor keeps turning out of the way. So now what you're going to notice is that the magnets point a little west, and then the motor turns faster as the magnets accelerate the motor. And then by the motor, I mean the compass motor, the whole armature. So as the magnets turn the compass motor north or clockwise, as the magnets turn the compass motor clockwise or the armature clockwise, the armature then goes faster than the magnets can go. And then the magnets turn north and east. And then the magnets actually slow down the armature. And then the armature slows down and comes to a stop. And then the magnets turn again and point west. And they accelerate the armature. And this will go on forever. This will continue forever. It never balances out. Now, the only way it can balance out is if the friction on this bearing up here, right, the friction on that bearing gets more and more as the motor turns faster and faster. So when the friction equals the amount of acceleration or angular acceleration that the magnets are creating on the motor, when the motor turns fast enough, the magnets will keep pointing west. And if that is exactly balanced, then the magnets will point west and the motor will go very fast. But what happens, as you can see here, is that that balance has to be so perfect. I mean, the least bit of change in the speed of the electric motor, the DC motor, or the least bit of change in the friction at the bearing up there, the least bit of change in that friction or the speed of the motor will cause the magnets to go out of phase. Let me slow the magnets down a little. They seem to be going a little too fast. So another way to make the thing balance out is to gradually accelerate the magnets or the electric motor, gradually accelerate the electric motor to the point where it's accelerating at the same speed that the compass is trying to turn. and then they will continue to point west. But you can only accelerate so fast, and then you're going too fast. So what happens is if the magnets go out of phase, so say it's going too fast, like we had before, if it's going too fast, now the magnets are out of phase. They're not turning, continuing to point west or westward. So once the magnets are out of phase, you're out of luck. There's no rotation. So what I want to get at is that there is no linear thrust or acceleration from this compass motor. And the reason why is because the armature is pulling the magnets around. It's not the magnets pulling the armature around north. Now, I established in previous videos that the magnets, when they turn from west to north, the north end accelerates a little faster, and that makes the thrust northward. And depending on the balance of the weight, the thrust can go various directions. So this won't happen with a compass motor. It will happen with the Virus boat, the Virus magnetic boat, which I have in other videos. So this won't happen with the compass motor because the magnets are not turning the motor is turning the magnets as it goes past north. The magnets are being pushed, the motor is being pushed against the magnets, but the mass and the magnet have to turn together to point north in order to make thrust. So this just won't do it. But one possibility now that I have in mind is that if I could turn the magnets quickly to point west and then stop them, and then let that pull the armature around north and a little to the east, then that would make forward thrust. That would make northward thrust. But these magnets are way too big for that because the magnets, the inertia on the magnets, when the magnets point, if I do that, let's make it go faster. And let's stop it. Now say I stop it and I turn the magnets enough to go west and then stop them. You see the motor is already turning, the armature is already turning. I could go west and stop. And if the magnets weren't so heavy, the armature wouldn't be turning that much. And the magnets would point all the way west. And then the compass effect, or the compass power of the magnets, would pull the whole armature around north. And the north end of the magnets being stronger, because I'm in the upper hemisphere of the Earth, the north end of the magnets will turn faster. So there'll be some centrifugal force that's uneven that will be pulling the north end of the magnets, and the part of the armature that's on the side of the north end of the magnets, that will be moving faster. That will be turning faster and have more centrifugal force. So that's my theory. That's my model. And what happened here is that the model, the 1000 RPM N20 DC motor, the gearbox jammed after quite a bit of use. So all I had left was this 60 RPM motor. So I put the 60 RPM motor on, and while I'm waiting for the new motors to arrive or be delivered, and this is what I saw. The magnets going, as you can see, the magnets turning west, and then the armature bringing them around east, and then the magnets turning west again, and the armature turning them around east, and so on and so forth. So that's all I got to say for today. Thanks for watching. Give me a like, a rumble, and subscribe.